Okay guys, everything is basically wired up now. The amplifier is turned on, plugged into the mains. I am feeding it a signal of around 100 millivolts at the input at the grid of the first 12 AX7 preamp stage. I have a 8 ohm dummy load. The volume is turned almost all the way down, and we can see on the scope the green trace is on the plate of the AX84. It is set to 10 volts per division. We have around 15, 16, something around that volts at the plate, and the yellow trace is on the load, so on the secondary of the output transformer, and we have around 240 millivolts. And adjusting the volume, I am not going to turn it up all the way yet because I am not yet sure if I have the correct load resistance, but so far everything seems to be working. So now I'm going to take a closer look at the voltage gains of each stage to see how it matches up with reality, with the how the reality matches up with the calculated approximations. And this is with a new set of new old stock tubes, both the 12 AX7 and the EL84. These came in the original packaging, and this basically fixed the issues with excessive plate current on the 12 AX7 stages. So it turned out to be the tubes. I'm quite thankful that now I don't have to mess with the biasing, and we are having a little bit higher B plus, but from what I can tell so far, we don't seem to be exceeding the maximum limits of any of the tubes. Alright folks, so I realized that I didn't give you all a close look at the circuitry from the coupling capacitor from the first preamp stage onwards. So let's do that now. So this is where we left off at the last circuit close look. So coming from pin 1 of the first half of the 12 AX7, we have this capacitor C3 going to the volume control, the potentiometer mounted on the front, and coming from the volume control, it's this shielded cable and that goes to this parallel. I need to heat up this heat shrink. I just realized that, but awkward. But ignoring that, we have the 470k resistor, and parallel to that is C5, and this is the base cutting network, and also that goes to the grid pin 7 of the second part of the 12 AX7, and also from the grid going to ground is this resistor, the base resistor 470k, and that this is sort of like a ground point, and from here we have a lead that goes back to the star ground. So that's the grid circuit. Now let's check out what's at the cathode. So this is pin 8, the cathode pin for the second half of the 12 AX7. and that goes here to the cathode bypass capacitor, and parallel to the cathode bypass capacitor is the cathode resistor, which is supposed to be 820 ohms. I bumped that up to 1k, and that goes again to the ground node. And this lead is actually coming, this is a ground lead, but it's coming from the volume control potentiometer. It is going here because I am following the grounding scheme of bringing basically all the ground points of each stage to the ground side of that particular stage. That particular stage's cathode. This is a grounding scheme as mentioned by Merlin Blenkov of valvewizard.co.uk. I shall put the link in the description. Now the plate circuit of the second preamp stage. This lead comes from pin 6. The plate goes to this point on the tach strip, and this is the plate load resistor, the 100k, going to the B plus node. So even the first preamp stage has its load resistor connected to this point. Back to the plate, that is pin 6, we have this capacitor, which is C2, the 270 picofarad capacitor, that forms the start of the tone stack, and this lead is going to the treble control pot. So you can trace this wire going to the treble control. So that makes up one of the filters of the tone stack. Also from the pin 6 node is R4, the 100k resistor, which is also a part of the tone stack, and that goes to this node on the tach strip, from where we have two capacitors branching off. Both are 15 nanofarads, and this one over here, that one goes to the base control through this lead right here, coming to the base control. And notice that these two pins of the base control are tied together, and from the remaining pin on the base control pot, we have this lead going all the way to the middle control, the mid control pot, and from the middle pin of the mid control pot we have this lead which is going to that other capacitor, which, like I showed you before, is tied here to R4. And this is the ground lead from the middle control pot going to this node over here, and this is the cathode ground for the power amp stage, the AX84 power output stage, and that ground is kept separate from the rest of the grounds here to avoid hum and to avoid causing a ground loop, and that goes back to the main B plus filter cap. And this grounding scheme was inspired by the writing of Merlin Blenkov of valwizard.co.uk. Now this lead on the treble pot is connected back to the bass control, and that is the FMV tone stack. As we see here, the output from the tone stack is from this lead so the output from the tone stack is going into this 6.8k or 5.6k resistor going to pin to the grid of the EL84, and before that, so this resistor is the grid stopper, and we have the main 2.2 meg resistance here, which I have here. It's supposed to be 2.2 meg, but I did not have any of those resistors, so I used 2 1 megs in series going to the main ground node for that stage, which again, like I said before, goes to the filter cap negative, and that is the grid circuit. At pin 3, the cathode, we have these hum reduction resistors coming from the filament wiring. This is sort of a virtual center tap kind of thing going on. You can take a look at the AX84 schematic and understand what this is. But anyway, this from the cathode pin, we have this lead coming here to the cathode bias resistors at this node. There are 2 resistors in series. This resistance was originally supposed to be 130 ohms. However, I have used, to reduce the quiescent plate current, I have used 2 100 ohms in series to give us 200 ohms. And this is a bypass capacitor, 100 microfarad, as used on the AX84 schematic. And I've been told, or I've heard, that this value might be too big a value, and that might give me very boomy bass, so I might play with that later. And again, this is the ground point. And now for the important part, the plate of the EL84. This is the plate pin 7, and that goes to one side of the output transformer, which is of course on the top of the chassis, and the other side of the output transformer comes here and goes to the main B plus point. Now pin 9 is our screen grid for the EL84, and I played around with this resistor like you saw in the previous video, and I settled for 2.2k, and that goes here to the screen grid voltage point. And I think I've already shown you the power supply section, but this is another voltage dropping resistor below here for the screen grid. This is the screen grid filter, and this is all the heater, the filament wiring. Now in the previous part of this vlog series, I mentioned that I wasn't yet comfortable with cranking the amplifier up because I wasn't sure if the speaker impedance matching was correct. This is because I pulled this transformer from the junk Philips radio that I showed you in part 1, and the speaker was missing, so I had no way of checking what speaker impedance was originally used, and therefore the transformer being designed to match that impedance to the EL84, because again I knew for sure that the radio used an EL84 output stage. So I did some research online and I asked some of the some people online, some of my online friends involved with the vintage radios and valve audio, and I got a lot of conflicting response as to what speaker impedance was actually used in these 1960s Philips radios, and also about the right way to connect these transformers, because I this transformer also has a separate choke winding for the power supply right next to the primary winding. So there was some confusion as to which one of these is the filter choke winding and which one of this is actually for the plate load, and also the taps which should be used on the secondary, because there is one tap which is for feedback. So I wasn't sure if the speaker should be connected between here and here or here and here like I have connected it. And there is some confusion because I don't have a schematic for the exact radio that I took this from, but looking at schematic from another similar radio and another wiring diagram, so one source showed the speaker connected between these two pins, but based on the test that I performed by injecting signals and trying to work out the turns ratio, that did not seem right to me. So what I did today was, so I tried once again applying a signal to various different combinations of which pins of the output transformer, and I tried to work out the turns ratio for different connections, and the only combination that is making sense to me is the way I have it connected already, and that is with these two pins going to the EL84, one side to the B plus and one side to the plate, and these two pins going to the speaker. That gives me a turns ratio of around 41-ish. Let's round that off to 40 because it varies a little bit based on the input voltage and also on the frequency. Okay, so impedance varies with the square of the turns ratio. So let's take 43 as our turns ratio, square that, and we have 1849. Now let's multiply that with various speaker impedances, starting with 4 ohms. That gives us 7396, pretty close to the 8K that is recommended as the reflected plate load in the EL84 datasheet. Let's try 6 ohms. Six times 1849, that equals 11,094, bit on the high side but still fine. So I guess either 4 or 6 ohms shall be fine, not perfect but fine, considering the inaccuracies of the turns ratio calculation. Again, it is the voltages in and out, I was getting inconsistent results based on the frequency and again the amplitude of the voltage, and I was using my scope, my hand hand tech scope to measure the voltages, and again the accuracy of the readings varies, depends on the volts per division setting, so these are not very accurate calculations anyway, but they appear to be somewhere in the ballpark. And again I was getting, so these are just a few values that I noted down today, but I've on these same windings I've gotten results ranging all the way from 40 to 45 for the turns ratio. So it's hard to be precise about this, at least with the equipment that I have, but at least I know that these are the correct windings, and either a 4 or a 6 ohm speaker should be approximately alright. So turns out that the speaker I used for testing yesterday in terms of impedance was not too wrong, and I could actually have cranked it up, but better be safe than sorry. This is a very ratty condition 4 ohm speaker that was removed from my car. It's a Sony, and I have another 4 ohm speaker inside of this. This solid state hard K guitar amp, so I guess I could hook it up to that and do some testing, hopefully play through it for a while without blowing anything up. I've actually got 6 ohm speaker in a cabinet ready to be used for this, but it is in storage and it'll be a day or two before I can get that. So I think what I'm gonna do now is power this on, inject a signal, and check the gains of each of the individual stages, and see how well they match up to the approximate calculated expectations. And if they're not too far off, I'll assume everything is okay. It should be safe to shred through it, or as much as I can shred with my rather rudimentary skill level at the guitar. And yep, hopefully it will be fine. I'll also recheck and note down all the plate voltages, and I guess we are almost done now. It's just in the testing phase. Okay, so I've got this on dummy load now, 4 ohms dummy load, and for some reason if I connect the scope ground to the amplifier ground, it just kills the signal. That is probably something to do with having the function generator built into the scope. So but we can still get a scope trace without the scope ground connected. I don't know how accurate that's going to be, but for now we are just going to do that. So now we are connected to the input, and I am feeding in around 100 millivolt peak. So now I'm going to move this. Okay, so I've connected the other channel to the plate of the first 12 AX7 preamp stage, and we are getting now the second channel is the green trace, and it's set to 2 volts per division, and we are getting around 5.28 volts out. So let's do the math, and the gain is pretty close to the estimated value of 56. We have 52.8. So this stage appears to be working correctly. Now let's move on to the second half of the 12 AX7. Alright, now the scope, the yellow channel, the first channel is set to 100 millivolts per division, and it is right before the grid resistor, the grid what you call the snubber resistor, and the capacitor, the base cut capacitor is right before that, and we have 2.8 millivolts at that point, and we are getting at the plate, 9.4 volts out. That gives us a gain of around 33, little bit lower than the expected 41, but I would say not too far off. That might be a result of me bumping up the the cathode resistor, but also we have to keep in mind that this stage is very much influenced by the loading effect of the tone stack, which is very frequency dependent. So this gain will vary on frequency. So considering that, we are not very far off. And also very interesting is the fact that altering the volume level also changes the gain level. I don't mean that relatively. If you look carefully, the relative amplitude of the input and output is not staying the same. I have done the math, and the gain is varying at different volume levels, so that is quite interesting. And I guess that is part of the intrigue and mystique about tube amps, all these mysteries, but everything seems to be working fine. Now the yellow channel on the scope is at the grid of the EL84 and the green channel is at the plate. We are getting around 840 millivolts going into the grid, or at the grid, because the grid doesn't really draw current, and at the plate we have around 63 volts, and that works out to around a gain of 37, not very far off from the expected value of 48, considering the approximations made to calculate all of this, such as the of turns ratio of the output transformer and so on. So yep, that is correct. Now, so this appears to be fine. So now let's try to check the gain at the load, and also finally work out the power dissipation, and let's see if we can get this to clip and what the distortion looks like. Now the yellow probe is on the dummy load, and the green probe is at the grid, and we have 840 approximately millivolts at the grid, and we are getting around 1 volt out. So that gives us a gain of around gain relative to the load of around 1.2, which is not again not very far off from the expected 1.92. And I've just dropped my dummy load. Alright, so the scope is still on the output. Let's try to work out the power. We are at the point where we are not into distortion yet, but if you go more than this, it starts to round off slightly. I guess that is the beauty of a valve amp. You don't get hard clipping, you get soft, a softer distortion, and it's kind of if you increase the amplitude more than this, it starts to not look like a perfect sine wave anymore. And at this point, if you use the formula, power is equal to voltage square divided by resistance, we are at around 1.4 watts, 1.44 watts. And so let's go higher and see what happens. Now we are at the point where the sine wave has started to look kind of squared out at the peaks, and at this point we are getting almost 3 watts, pretty good. Now let's turn out the volume and see what this thing will do balls out. We are now at 4 volts at the output, quite a lot of distortion. We almost have a square wave now. Increasing the volume doesn't really give us more amplitude out, and 4 volts across 4 ohms, that is around 4 watts. Of course that is the peak, so 2 watts RMS, quite a bit lower than the 5 watts RMS that we predicted, but that's good enough for me. And yep, I think that's pretty fine. Let's see what happens if we increase the signal in amplitude. Let's go to the signal generator. Let's put in 0.5 volts. Back to the scope. Yep, it's still around 4 volts. 4 volts is where it peaks out. So this is a 2 watt amp, I would say 2 watt max, distorted, and around 1 watt if you want a clean output. So pretty satisfactory performance. Now I am really tempted to plug this in and rock out, as the cool kids would say. Everything seems to be fine. It hasn't blown up yet. I guess we can finally see how this sounds. Exciting.